Hello, welcome back to Every Problem. This is Stewart Calculus 8th edition, section 1.4, problem number 18. 18 is probably the trickiest one we've had so far. It says, starting with the graph y equals e to the x, find the equation that results from, and we have a and b, reflecting across certain lines. One of them is y equals 4, the other is x equals 2. So this will take some careful thinking, but we'll definitely get through it. So we start with the function y equals e to the x, and it takes this general shape. We have the asymptote right there. And, well, hold on, let me draw a cleaner x-axis. There we go. We have the asymptote here. We have the point 0, 1. And the graph will look just about like this. So if they want us to reflect this along the line y equals 4, then this 0, 1 here, well, first off, what's going to happen is if you flip a graph along the if you flip a graph along a horizontal line, then it's going to go from this shape to this shape. Okay? So the graph is now going to have some downward shape like this. And if we can use this point 0, 1 to our advantage. If it's 0, 1, they want us to reflect it about y equals 4, then we can actually just count 1, 2, 3, and then another 3. 1, 2, 3. And that would be our new point. So that would be 0, 1, 2, 3, 4, 5, 6, 7. So that means that let's see, let me just count correctly. That means that our new point at x equals 0 would be 7. So if we have y equals e to the x plus some mystery number, and we know that e to the 0 equals 1, then y equals e to the x plus plus 8. And the reason for that is because we can note that in our original function, the asymptote was 1 below the point 0, 1. The asymptote is at 0. You go up and you reach 0, 1. Now, when we reflect, the asymptote also reflects. So it's going to go from 1 below 0, 1 to 1 above 0, 1. So now the asymptote is going to be up here. Okay? So now we have that, but also anytime you reflect a graph that way and it changes shape, as we saw over here, it's going to have this big downtrend with an asymptote at y equals 8. That means that we're going to have a negative value, a negative coefficient in front of our e to the x. So we'll apply that. And that's our final function. Let's go ahead and graph it. So we have an asymptote at y equals 8. Our x equals 0 point is going to be 7 because we will have a negative value here in front of the e. So e to the 0 equals 1, but don't forget this negative, -1. Plus what equals 7? Well, -1 plus 8 equals 7. So I'm sorry if I didn't explain that as clearly in the beginning, but I hope it makes sense now. So there we have it. The graph is going to decay as we go more towards the asymptote, and then it's going to grow in the negative direction very quickly as well. It's maybe not the smoothest curve, but there we go, that's smoother. And yeah, as long as we mark that this line here is equal to y equals 8, and the function y equals negative e to the x plus 8. Now that's only part 1, right? We have part 2 also. So part 2, reflecting about the line x equals 2. Okay, so let's do that. They want us to take our function b to the x and reflect it along this line. So that means our graph is going to kind of flip a little bit. It's going to flip and be shifted over. So that means our x value is going to need to be negative, and we'll have to change something about it. So we know that we're going to have e to some negative x, but there will also be a translation as well, because you'll see if here, yeah, that's good. If here we have 0, 1, that's 0, 1, we reflect it along 2 here, so we have 1, 2, takes 2 units to get to the line of reflection, so then we move 2 more units. 1, 2. So that's going to be our new, so to say, 0, 1 point. But really it's going to be 4, 1. So how do we get that? Well, we'll have to think backwards a little bit. So let's take this. Let's have y equals e to the negative x plus some constant. We'll say b. And when y equals 1, 1 equals e to the negative, so negative value, the x input, as we see here, is 4. Sorry, parentheses were wrong. E to the negative 4, because that is our input value once we reflect it. But plus b, well, we know that e to the 0 equals 1, so we know that negative 4 plus b needs to equal 0, so b equals 4. That means that we have 1 is equal to e to the negative 4 plus 4. Okay, good. So now we can have our x value just as a normal variable again, and we'll rewrite this. We have y equals e to the negative x plus 4. And that is going to be our function for this.